Good afternoon, everybody in Year 12 Physics at Whangarei Boys High. I'd like to work through an example from the homework. Today is the 15th of March 2022, 15 Po 2 Tarangi. And I'd like to look at the example. The question is going to be question 8 on page 111. And this is this one here. Cricket ball leaves the bat with a speed of 30 meters per second, which is about 108 k's. At an angle of 41 to the ground, almost 45. The boundary is 100 meters away. Does the player hit a 6 and get the ball over the boundary? That's what's going on here. We need to find these things. We need to find the initial, I forgot to write initial, but it doesn't matter, horizontal, initial horizontal, and initial vertical velocities. We'll then use one of those to find the hang time. The vertical velocity will help us find the hang time, the time that the ball is off the ground and traveling through away from the ground, and we need to find the travel distance, which is what the question's all about. So we have ourselves, this is the velocity of the ball leaving the bat, 30 meters per second, 41 degrees above the horizontal, shooting away. And then we also need to find the horizontal velocity, which I've drawn like that, and the vertical velocity, which I've drawn like that at that time. Now I've labeled them VH, VV, and let's find, now if I go back a moment, because vertical and horizontal are by definition right angles to each other, we can put a right angle in there. Then we have ourselves, excuse me, a Year 11 trig situation. We've got a right angle triangle with one angle and one side length we know. We can find the others. Using Year 11 trigonometry and dealing with the horizontal velocity, I'm going to say that the cosine of this angle is equal to the adjacent, which is VH, divided by hypotenuse, 30, car, so car, cos, adjacent, hypotenuse. Cos of 41, adjacent over hypotenuse. Then I don't want to have what I'm looking for on the right-hand side. I want to have it on the left. So I'm going to swap sides by just writing it like that. VH over 30 is cos 41. I don't want VH cluttered up by being divided by 30. I want it by itself, so I'm going to multiply it by 30 to get times 30 divided by 30 is just VH, and then I'm going to have to multiply the other side by 30 to keep the equal sign working, like that. Then we find cos of 41, which is about that, a bit over 3/4, and then we multiply it out and we get that 22.64 meters per second across the ground to the right. Cool. That I've colored orange because that's what the horizontal velocity vector is. Next thing, similarly with the vertical velocity, the sine of this angle is opposite over hypotenuse, sine 41, VV over 30, that's cool. Swap sides, multiply both sides by 30, and then put them and find the sine of 41, multiply that by 30, we get the vertical velocity upwards, in purple is 19.68 meters per second up. You can summarize this down below, and you feel free to click the old pause button whenever you feel like it. Now let's use Mr. Henderson's handy dandy super duper projectile motion method. Two separate kinematic situations with their own equations, but they both take the same amount of time, so we'll make and use this little T-chart. Horizontally and vertically, write down the things that we need, two different kinematic situations at once. They have the same amount of time. When it finishes going down vertically, it finishes traveling horizontally because it stops. Well, in this case, it's finished flying. And we know that the horizontal velocities are constant. In other words, the horizontal acceleration is 0. And vertically, it's going to fall at a rate of 9.8 meters per second squared. That's acceleration. If the horizontal acceleration is 0, then the initial and final horizontal velocities will be the same. And you can do all this without even starting the question. Now we can start putting things in. Horizontal velocity, that's initial, is 22.64. No acceleration, so is the final. That's cool. And we also know that the initial vertical velocity is 19.68 meters per second up. I'm going to call that positive. I'm going to call that negative, which means I have to change the sign, the SIGN, not SINE. Change the positive and negative thing in front of the 9.8, because if that's positive velocity, acceleration, whatever. This is negative acceleration. Then we put in some things that we also would like to find. We'd love to find the horizontal distance. That's the whole key here. Vertically, it's going to go up, it's going to come down, but it will finish up at the same height it started. So vertically, no change. Projectile motion is symmetrical. So the initial vertical velocity will be the same size, but the opposite direction when we look at the negative, when we look at the final velocity. So put a negative in there. Now we can do some equations. I'm going to choose this one because that ties together some of the things I know with what I'm looking for. And again, I'm looking for t, and it's cluttered up with this other stuff. So I'm going to swap sides, make it on the left-hand side. Then I'm going to subtract vi from both sides. That gets rid of that is positive, that negative, that goes. F of at is vf minus vi. Then t is cluttered up by being multiplied by acceleration. So I divide both sides by acceleration. At divided by a is just t. My dog is snoring in the corner. Sorry about that. The trials are working at home. And then we have the right-hand side, difference of the velocities divided by the acceleration. Gives us the time. T is that. Let's put some numbers in. Negative 19.68 is the final velocity, minus positive 19.68. Going to give us a big negative number divided by negative 9.8. So roughly, kind of, sort of, we look at initial upwards velocity is 20, roughly, and initial downwards acceleration is 10. So it's going to take 1 second to go to from 20 to 10, and another one to go to 0. So that's 2 seconds up, another 2 seconds down, makes roughly 4 seconds, and the calculation looks about right. Looks pretty good. We can put that in there. We also know that it's the same time for horizontal. Very useful. Now we can do d equals vit plus a half at squared, but we know a is 0. So we don't have to have half at squared, because half times 0 times t squared is going to be 0. D is just vt, like year 10 work. D is 22.64 times 4.02, and that turns out to be 91 meters-ish, and that is not the answer. Often in an exam, students will finish there, and that is worth a merit. The excellence part includes answering the question, reading the question carefully. The question says, does the cricket player get a boundary, get a 6, by going more than 100 meters? The answer is this. The player does not get a 6. The ball did not travel more than 100 meters without hitting the ground. Physicists and engineers solve questions for people. People don't want to know the distance that the ball goes. They want to know, does the cricket player get a 6? So we need to answer that. I think that's us pretty much sorted. Thank you for following through, and I hope this helps you with the homework, everybody. See you when I come back, eh?